Now, as an introduction for us to understand the reinforced concrete design, because I don't want you to be merely memorizing the formulas, so when it will be twisted, then with the entry of COVID, all schools and review centers were forced to stop their physical operation. All shifted to online. Different centers use different advertising tricks and gimmicks that cause more confusion in the minds of reviewees and students rather than help them. But in order to give you clear idea on what you will actually experience in our online review, we created this channel so that you will see, know, and experience firsthand how we do it online. But before we begin our discussion today, please don't forget to visit, like our FB page, Padilla Review Center. The link is found below. Please also subscribe in our YouTube channel. Please don't forget to click the notification bell. Choose all so that you will always be updated and notified regarding all our posts. Also, please don't hesitate, and we will appreciate it if you will like every post that we will make. This is for all of you who are reviewing and students of math, science, and engineering, most especially civil engineering. So if you have problems or questions or topics that you want us to discuss, just send it to us through our contact numbers below. So let's begin. Let me have a discussion in reinforced concrete design, and let me begin with working stress or elastic design method. Now, as an introduction for us to understand the reinforced concrete design, because I don't want you to be merely memorizing the formulas, so when it will be twisted, then our mind will also be twisted. So let us begin with the fundamental. For example, I have here a wood section. The only difference between concrete and wood are the strengths, or is the strength, the parameters, but basically the design concept will be the same. Okay? Now, so for example, I have here a wood section assumed to be prismatic and homogeneous, 200 by 400. The allowable bending stress is 12 megapascal, and E, the modulus of elasticity, is 4 gigapascal. We are asked here to find the moment capacity of the section. So, let us solve it. Now, since we have here allowable stress, in order to use that, we will have here the equation of safety. So, our equation of safety is this. In order for beam to be safe in flexure, the requirement is simple. The maximum actual bending stress must be less than the allowable bending stress. Normally, we designate the actual stress by small letter, the allowable stress by big letter. So, actual bending stress due to moment or bending, this is given by MC over I, right? Our section here is rectangular. MC over I will reduce to 6M over BD squared. Let me emphasize this. The 6MBD squared conversion of MC over I, this applies only for rectangular section. And this one represents the maximum stress, meaning the stress only at the ends, topmost and lowermost. Now, in MC over I, the I here is I about the neutral axis. Obviously, the neutral axis of this is at the middle. Neutral x-axis. Okay? So, the C here is the distance of the point or of the element from the neutral axis. If you want the stress here, your C is this. If you want the stress here, the C is this. So for maximum stress, the C must be maximized. You get it? Okay. So this must be less than or equal to FB allowable. So all we need to do is substitute the values R6 times M. This would be our moment capacity over B, 200 times 400 squared must be less than FB allowable, which is 12 megapascal. Megapascal is Newton per millimeter squared. Since I am using here Newton and millimeter, these are millimeter, your M here is to be expected in Newton millimeter. So solving our moment capacity here, the moment capacity must be less than or equal to 64 times 10 to the 6 Newton millimeter. So Newton, 1000 Newton is kilonewton, 1000 millimeter is meter, 1000 is 10 to the 6. So 10 to the 6 Newton millimeter is kilonewton meter. I repeat here. 1 kilonewton meter is 1 kilonewton, 1000 Newton. 1 meter, 1000 millimeters. So 1000 times 1000, that is 10 to the 6 Newton millimeter. So 1 kilonewton meter is 10 to the 6 Newton millimeter. So therefore, our moment capacity must be less than or equal to 64 kilonewton meter. You follow? So for reinforced concrete, singly reinforced working stress design, we will subscribe in this channel and we will be posting the part 2 of this discussion. And by the way, on March 15, we will be starting the first batch of our program for reinforced concrete design. It would be RCD 1 and RCD 2. RCD 1 will be reinforced concrete beam and slab. RCD 2 will be column and footing. The fee for RCD 1 is 1,000. The fee for RCD 2 is 1,000, only 2,000 pesos. But if you will enroll on or before and you are also a subscriber of this channel, so you have to just send us with your payment, with your picture proving that you are a subscriber of this channel, then you will be getting a 50% discount. So you will be paying only 1,000 pesos for the 2. So the RCD 2 will be free. Imagine why you must enroll. 1, it's very affordable. Because if you will hire an instructor or a tutor to teach you, it's 500 per hour. If I have time, I accommodate tutorial, but my rate is 1,000 per hour. But I rarely accept tutorial now because of the so hectic schedule that I have. So if that's 1,000 per hour, but if you will enroll in this program, this is about 30 modules. Okay? So this would be 30 modules. And each module is more than 60 minutes computer teaching hour. Iba yung computer teaching hour, iba yung actual teaching hour. Kasi sa computer teaching hour, remove, reduced, eliminated yung mga dead air. Meaning, air that are, or meaning time that are wasted. Okay? Errors are eliminated because these are edited, no? So, the pictures also the video are edited. So you don't have any wasted time. In fact, a 1 hour 30 minutes video lecture is equivalent to 4 hours actual lecture in a physical setting. So meaning, if that is 30 modules, assuming 1.5 hours teaching hours in online, so we will be having 4 times 30, that is equivalent to 120 physical hours. Times 1,000, that is basically 120,000, and you will be paying me only 1,000 if you will be able to avail of the discounted price. So that discount is valid until we decide to pull it out. So it is still on board. If you decide to enroll, you will be getting an access to our RCD Reinforced Concrete Design lectures and trainings. But also, if you enroll, you can also ask questions in case you have something you don't understand. And the beauty of this program is you can view the lectures again and again and again. Each of you will be granted for the program, for the entire program. For example, RCD 1 and RCD 2. For RCD 1, you'll be granted 3 months access. For RCD 2, you'll also be granted 3 months access. So, if you want to revive it, then you just have to pay a minimal fee. Meaning, if you want to extend the 3 months, then you will have to pay that amount. Okay? So, for the entire program, RCD 1 and RCD 2, you'll have a continuous access for 3 months. Okay? So, that is continuous time. 1.5 months for RCD 1, 1.5 months for RCD 2. So, that would be continuous. You get it? So, I hope you will really enroll, and I hope that I could help you with RCD. Join me, enroll in our training. Okay? So, see you